let us try to understand these concepts with the help of few examples. Okay, so let us take first example to be x of t equal to e power j omega naught t plus theta naught. So we are asked to evaluate the even and odd part of a signal. So before we jump into the solution, let us write down this as e power j theta naught into e power j omega naught t, because we can split the signal. Now to find the even and odd part, we need x of minus t, and hence x of minus t would be equal to e power j theta naught, we don't have any t there, multiplied with e power minus j omega naught t. So that would be our x of minus t. So to find even part, first what is that we have to do? We have to add x of t and x of minus t. So that should be equal to e power j theta naught is common for both of them. So you get e power j theta naught multiplied with e power j omega naught t plus e power minus j omega naught t. So this simplifies to 2 e power j theta naught cos omega naught t. So this implies what happens to the even part. Even part is nothing but x of t plus x of minus t by 2. So that turns out to be e power j theta naught. 2 is gone. So e power j theta naught cos omega naught t. So that would be the even part. To find odd part, what is that we have to do? So we have to subtract x of minus t from x of t. So you get x of t minus x of minus t. So this is our x of t, and this is our x of minus t. If you subtract, what happens? Again, e power, I'll write down here. So that should be equal to e power j theta naught is common. You can take it out. So you will get e power j omega naught t minus e power minus j omega naught t. So that simplifies to 2j e power j theta naught sine omega naught t. Why? E power j theta minus e power minus j theta is 2j sine theta. What is theta for us here? It is omega naught t, and hence now what happens? Our odd part is given by xo of t equal to x of t minus x of minus t divided by 2. That turns out to be j e power j theta naught multiplied with sine omega naught t. So in that way, we can evaluate the even part and odd part of the given signal x of t. So we'll take one more example, which is given by x of t is equal to 1 plus t cos t plus 1 plus t square sin t. So again, what is that needed here? First we have to find out x of minus t. So that turns out to be 1 plus, wherever there is t, we have to replace with minus t. So minus t cos of minus t plus 1 plus minus t whole square multiplied with sine of minus t. So if you expand this out, you get cos of minus t is cos t itself. So you'll get 1 minus cos t. So this would be 1 plus minus t whole square is t square. Sine of minus t is minus sine t. So you will get minus 1 plus t square multiplied with sine t. So this is our x of minus t. So to find xe of t, so we have to add x of t and x of minus t, correct? So you get x of t plus x of minus t divided by 2. So that is our even part. So if you do that, what do you get? You have to add these two. So here I forgot to write t here, sorry. So what happens if you add these two guys, t cos t will get cancelled, 1 plus t square sine t also will get cancelled. So finally what do you get? 1 plus 1, which is 2, 2 divided by 2 is 1. Okay. So other two signals will get cancelled out, and finally you get even part to be equal to 1. But if you look at our x of t, we know that x of t is nothing but xe of t plus x of t. So that is what we have studied, right? So to find odd part, see there are two ways here, right? So what is that? You can subtract x of minus t from x of t and divide by 2, or if you are a bit smart, from this equation itself you can get. So we got x of t, we got xe of t. So xe of t is 1, and hence what happens? Xo of t would be equal to how much? That is nothing but x of t minus xe of t. So because xe of t is 1, what would be the final answer here? 1 will get removed, so you get finally t cos t plus 1 plus t square multiplied with sin t. So that would be the odd part. So you can get even from the regular expression. What is that? X of t minus x of minus t by 2. So that is also possible. By using this also you can get the answer. Okay, so that is as far as continuous time is concerned. We'll take one more example. So we want the even and odd part of this signal. Okay, so let me, x of t is given by what? 1 plus jt multiplied with e power jt. So let us expand this. So you will get x of t to be e power jt plus jt times e power j 3t. So you'll get e power j 3t plus jt times e power j 3t. So now to find the even and odd part, first we have to know x of minus t. So that should be equal to, wherever there is t, you have to replace with the minus t. So you'll get e power minus j3t. So here also you have t, replace that with minus. So you'll get minus t, you'll get minus jt multiplied with e power minus j3t. Okay, so what is even part? So to get even part, you have to add x of t and x of minus t whole divided by 2. So that would be equal to how much here? So e power j3t plus e power minus j3t would be equal to 2 cos 3t. Okay, plus, and in these two jt is common, so you will get jt common, and e power j3t minus e power minus jt would be 2j sine 3t. So that would be 2j sine 3t divided by 2. So j into j is minus 1, so 2 is in numerator and denominator, that flow will get cancelled. So what will be the final answer? Cos 3t, j into j is minus 1, so you will get minus t sine 3t. So that would be the even part of the given signal. So similarly, to find odd part, what is that we have to do? We have to subtract x of minus t from x of t. So what will happen? So I'll write the equation here. Xo of t is equal to x of t minus x of minus t divided by 2. So that turns out to be e power j3t minus e power minus j3t. So that should be equal to 2j sine 3t, and then again jt e power j3t minus of minus is plus, so we'll get plus jt common, and you get e power j3t plus e power minus j3t. So that should be equal to 2 cos 3t whole divided by 2, and again 2 is common, that fellow will get cancelled out. So what will be the final answer? So you will get j sine 3t plus jt cos 3t. So that would be the odd part of the signal. So in that way, whatever may be the signal, so depending upon the problem, you can find the even and odd part of the signal using multiple ways. Okay, so next let us jump into an example for discrete time case. So signal is given to be x of n equal to 1 by 1 plus jn, and we are asked to evaluate the even part and odd parts of the given signal. So x of n is given to be 1 plus 1 by jn. So again, to find even and odd part, we need x of minus n. So that turns out to be wherever there is n, you have to replace with minus n. So you get 1 by 1 minus jn. So what will be the even part of the signal? That should be equal to again x of n plus x of minus n divided by 2. So that turns out to be how much? 1 by 1 plus jn plus x of minus n would be 1 by 1 minus jn whole divided by 2. So that simplifies to how much here? So if you take LCM, and you can easily see that jn will get cancelled out. So you will get 2 divided by 1 plus jn 1 plus jn multiplied with 1 minus jn would be 1 plus n square whole divided by 2. So these two will get cancelled, and finally you get the answer to be 1 by 1 plus n square. Similarly, to get odd part, we need x of n, which is nothing but x of n minus x of minus n by 2. So let us do that here. So what will happen? So our xo of n would be equal to x of n is 1 by 1 plus jn minus x of minus n would be 1 by 1 minus jn whole divided by 2. So that turns out to be how much? Minus 2jn divided by 1 plus n square whole divided by 2, and that 2 will get cancelled out, and finally you get the answer to be minus jn divided by 1 plus n square. So that would be the, in that way you can find out the even part and the odd part of the given discrete time signal. Okay, so let us take one more example. So this problem looks similar to what we have already done for continuous time case. So this one I will give it as homework. Okay, find xe of n and xo of n. Okay, find xe of n and xo of n. So this is our homework problem. Okay, so we'll take one more example, but now let us again come back to continuous time case, and we will solve finding the even and odd part of a signal for graphical case. Okay, so what do we mean by that? So the signal x of t is given to be this. So it's a trapezoidal function, and we are asked to find the even and odd part of the signal. So to this signal is neither even nor odd. Why? Because it is not symmetric. I mean, whatever you have from 0 to infinity, you don't have from 0 to minus infinity, and hence this signal is neither even nor odd. Okay, so how do you find the even and odd part? So we know that xe of t is how much? For whatever may be the signal, xe of t is nothing but x of t plus x of minus t by 2, correct? So to find the even part, first we should know x of minus t. So how do you plot plot of x of t is given? So we have to plot x of minus t. How do you get that? It is nothing but the rotation of the signal along y-axis by 180 degrees. So what do I mean by that? You rotate the signal by 180 degrees. So you get 180 degrees along the y-axis. So if you rotate the signal along the y-axis, you get x of minus t. Okay, now what is that we have to do? We have to add these two signals. Okay, what happens here? So let me directly show you how does the plot look and explain that. Okay, so this is our x of t and this is our x of minus t. We have to add these two signals and then divide by 2 to get the even part. So how do I do that? We will do by step by step. So from minus 2 to minus 1, this signal is 1. Minus 2 to minus 1, this signal is 0. So 1 plus 0 would be how much? It is 1, and we have to divide by 2, and hence you get a rectangle signal of amplitude half. Okay, why that half? Because what is xe of t? We know that xe of t is nothing but x of t plus x of minus t by 2. Correct. So this 2 brings you this value 1 by 2. Okay, then what happens from minus 1 to 0? Minus 1 to 0, this value, x of t value is 1, but minus 1 to 0, what is the value of x of minus t? We can easily see that equation of that line would be 1 plus t. Okay, so from minus 1 to 0, this is 1. From minus 1 to 0, this is 1 plus t. So you get 1 plus 1 plus t, which is nothing but 2 plus t, and then you have to divide by 2. So 2 plus t by 2 would be equal to 1 plus t by 2. So that would be the equation of that line. Is that okay? So we have here we have 1, here we have 1 plus t, so you have to divide by 2. So you will get 2 1 plus t whole divided by 2, which is 1 plus t by 2. Then from 0 to 1, what happens? So you can easily see that equation of this line is 1 minus t, and from 0 to 1, this fellow's value is 1. So if you add, you get 1 minus t plus 1, which is 2 minus t, divided by 2 would be how much? 1 minus t whole divided by 2. So yes, and from 1 to t, what happens? You have this signal is 0. From 1 to t, this signal is 1. If you add 0 plus 1, that should be equal to 1, and again you have to divide by 2, and hence you get half, and beyond that, that is 0. So definitely this would be the even signal. So you can easily see that it is symmetric about y-axis. Okay, so in that way you can find and plot the even part. Okay, so similarly, how do you find odd part of a signal? So we have plotted the even part of a signal, and how do you plot the odd parts? We need x of t minus x of minus t by 2. We have to subtract x of minus t from x of t. So you can see from minus 2 to minus 1, x of t is how much? 1. Correct. So from minus 2 to minus 1, that amplitude is 1, and from minus 2 to minus 1, this fellow's amplitude is 0. If you subtract, what happens? 1 minus 0 would be equal to 1, and again you have to divide by 2, and hence you get half. Okay, so what is our xo of t here? Xo of t is nothing but x of t minus x of minus t by 2. So 1 minus 0, which is 1, divided by 2, which is equal to half, or 0.5. Okay, so from minus 1 to 0, what happens? So from minus 1 to 0, what happens? This fellow is 1, and we know that the equation of this line is 1 minus t. So if you subtract, sorry, equation of this line is 1 plus t. So if you subtract, what happens? 1 minus of 1 plus t, that should be equal to, so 1 will get cancelled, so you will get minus t. So that fellow should pass through origin. So equation of that line would be minus t, and you have to divide it by 2. So on, hence equation of that line finally will become minus t by 2. Then what happens from 0 to 1? So from 0 to 1, equation of this line is 1 minus t, and from 0 to 1, amplitude of the signal is 1. So if you subtract, what happens? You will get 1 minus t minus 1, that should be equal to minus t, and again why 1 will get cancelled out, and what is left out? Minus t is left out, and you divide it by 2. So you will get minus t by 2. So equation of that straight line remains as minus t by 2. Okay, and from 1 to 2, what happens? This line, this value is 0, and from 1 to 2, this value is 1. So 0 minus 1 would be minus 1, and again you have to divide by 2, and hence you'll get minus 1 by 2, which is same as minus half. Okay, in that way you can find and plot both even and odd part of the signal when graphical notation is given. We will do the same thing for discrete time case. So we are given the signal x of n, which is of this form. So this is our x of n. So this signal exists from 0 to infinity with value 1, and for all other values it is 0. Okay, so again, to find the even part, what is that we should know? We should know x of minus n. So what is x of minus n? It is again rotate the signal x of n along y-axis by 180 degrees, and this would be our x of minus n. So to find the even part, what is that we have to do? We have to add these two guys. So if you add these two guys, what do you get? So if you add these two guys, what happens here? So look at x of n, that fellow is 0 for all values of n less than 0. So, and what about x of minus n? That fellow's value is 1 for all values of n less than 0. So, x of n plus x of minus n. So, if you add 0 plus 1, so that should be equal to 1, and anyway you have to divide it by 2, right? Y x e of n is nothing but x of n plus x of minus n by 2. So all zeros plus 1 is 1, and divided by 2 will give you this values, all values to be 1 by 2 or zero point 0.5. And again, be careful at 0. So at 0, what happened? This value is 1, and at 0 this value is again 1. So you'll get 1 plus 1, and you have to divide by 2, and hence you get 1 at 0. Okay, so 2 by 2 will be 1, and again for n greater than 0, what happens? X of n is 1, and for n greater than 0, x of minus n is 0. If you add, what happens? You'll get all ones plus zeros, that should be equal to 1, and again divided by 2 will give you half. So in that way you get xe of n to be this signal. So it is an even signal. So in a similar fashion, you can find out even the odd part of a signal. So what is the odd part of a signal? So odd part of a signal is nothing but xo of n, which is nothing but x of n minus x of minus n whole divided by 2. So x of n is this, x of minus n is this. So if you subtract, what happens? So for n less than 0, right? So for n less than 0, what happens here? So this value is 0, and this value is 1. So 0 minus 1 would be minus 1, and you have to again divide by 2, and hence you get minus half for n less than 0. At 0, what happens? The amplitude of the first of the x of n is 1, and the amplitude of x of minus 1 is also 1. So if you subtract, it will become 0. And after that, what happens? For n greater than 0, x of n is 1, and for n greater than 0, x of minus n is 0. So if you subtract, you get 1 minus 0, which is 1, and then you have to divide by 2, and hence you get 0.5. So in that way, either for continuous time case or discrete time case, we can find out the even and odd part of the signal using graphical notation, or if the signals are given in algebraic notation, I mean like in equation form, then also we can find out the even and odd part of the signal. Okay, so with that, I will stop this lecture, and remaining things we will see in the next lecture. Thank you.